Welcome to our channel Learning Math. In this video, we're going to learn about adding and subtracting fractions. To understand how to add and subtract fractions, first of all, let's solve some activities together. In this activity, we have to color three parts of the band. Let's color them together. As you see, we can color any three parts we want. Well, now what is the fraction representing the colored part? If you note something, how many parts did we color? 1, 2, 3. Well, out of how many parts we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have colored 3 parts out of 9. Now we can say that the fraction representing the colored part is 3 over 9. Well, in part B, color 2 more parts. Let's color them together. Now what fraction represents the new colored parts? We have just colored only 2 parts. Out of how many parts in all? There are 9. So the fraction representing the new colored part is 2 out of 9, so it's 2 over 9. Well, what fraction represents the whole colored part? In all, how many colored parts are we having now? Aren't they 5 parts? Look at them. 1, 2, 3, 4, 5. Out of how many parts in all? There are 9. So the fraction representing the whole colored part is 5 over 9. Now complete the following here. As you see, we have 3 over 9 plus 2 over 9. What do they represent for us? If you note, 3 over 9 represents the colored part at the beginning, plus 2 over 9, the 2 colored parts that we added. Well, in all, didn't they give us 5 colored parts out of 9? So it's 5 over 9. Well, if you note something, when we added 3 over 9 plus 2 over 9, we got 5 over 9. The denominator 9 remained the same, while we just added the numerators 3 plus 2. So here we can get a conclusion. To add fractions, we should keep on the same denominator and we only add the numerators. Well, now what about subtracting fractions? As you see here, we have also an activity. What is the fraction representing the colored part in the figure? If you note, how many colored parts are we having? 1, 2, 3, 4, 5. Out of how many parts in all? They are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We are having how many parts? 5 out of 11. 5 colored parts out of 11. We say the fraction representing the colored part here is 5 over 11. Now in part B, erase 2 of the colored parts. We need to erase 2 of them. Now what remains? Aren't they 3 colored parts? Out of how many parts in all? Out of 11. What is then the fraction representing the colored part? Isn't it 3 over 11? Well, now in part C, complete 5 over 11 minus 2 over 11. What should it give us? If you know something, 5 over 11 represents the colored parts at the beginning out of the band. Minus, we have erased, it means subtracted. 2 over 11, it represents the parts that we have just erased them. Well, equals what? How many colored parts remaining for us? Aren't they 3 out of 11? So the answer should be 3 over 11. Well, here also if you know something, 5 over 11 minus 2 over 11, it gave us 3 over 11. The denominator 11 remained the same. While we just subtracted the numerators 5 minus 2, it gave us 3. So here we can conclude that to subtract fractions, we should keep on the same denominator and subtract only the numerators. Well, in general, to add or subtract fractions, we need to transform into the same denominator. What does it mean, transform? Sometimes we don't have the same denominator. Here we're going to learn how to transform them. If we don't have the same denominator, we should transform into the same denominator, which should be the least common multiple of the given denominators, and then we should add or subtract only the numerators. Let's have an application to understand it more. In this application, we need to solve 5 over 4 plus 3 over 8. If you know they have different denominators, here it's 4 and here it's 8. Also, we need to subtract 7 over 5 minus 1 over 2. Let's solve these applications together. Well, 5 over 4 plus 3 over 8. The first denominator is 4 and the second is 8, different denominators. How to think about it? Can we multiply 4 by any number to get 8? Why do we think about multiplication tables to have the same denominator? If you know something, we can multiply 4 by 2 to get 8. Sure, as we multiply the denominator, we should multiply also the numerator. Well, now if you know something, let's solve it together. 5 times 2 gives us 10. Over 4 times 2, it gives us 8. Also plus 3 over 8, we copy it the same. Now if you know something, we have the same denominator. Both fractions are over 8. Well, now we just have to add the numerators. 10 plus 3, it gives us 13 over 8. Let's solve the other example. Here we have it 7 over 5 minus 1 over 2. We have different denominators, 1 over 5 and the other over 2. Well, if you know something, let's look at the smaller denominator. It's 2. Now, can we multiply 2 by any number to give us 5? Sure, no. What should we solve right now? In this case, we should multiply 2 by 5 and 5 by 2. Note that when we multiply 5 by 2, we get it 10. Also, we should multiply 2 by 5. 2 times 5, it gives us 10. So, when we can't multiply the smaller denominator by any number to give us the same as the greater one, we should multiply each of the denominators by the other. So, we multiplied 5 by 2 and 2 by 5. Now, we should multiply the numerators the same as denominators. So, we multiply 7 also by 2 and we multiply 1 also by 5. Now, let's multiply them. 7 times 2, 14. Over 5 times 2, 10. Here also 1 times 5, 5 and 2 times 5, 10. Minus, we copy it the same. If you note, we have here obtained the same denominator. Both fractions are now over 10. Now we just subtract the numerators. 14 minus 5, it gives us 9 over 10. The denominator 10, we copy it the same. Well, now what happens if we add or subtract a number with a fraction? How to solve it in this case? If you know something, 4 plus 3 over 2. Can't we write 4 as 4 over 1? If there's no denominator, then it will be over 1. Well, here how to solve in this case? The first fraction has a denominator 1, the second has a denominator 2. Now we can just multiply 1 by 2 to get it 2. We transform into the same denominator. And sure, we multiply numerator same as denominator. Now we can solve that. 4 times 2, 8 over 1 times 2, 2. Plus 3 over 2, we copy it the same. Now we are having the same denominator, which is 2. We can just add the numerators. 8 plus 3, 11 over 2. Sure, the denominator 2, we copy it the same. The same in subtracting. Here, as you see, 5 minus 7 over 3. 5, it has no denominator, so we can write it over 1. Now we should transform into the same denominator. So we can multiply 1 by 3 to get it 3. Sure, we multiply the numerator same as denominator. Now 5 times 3, isn't it 15? Over 1 times 3, 3. Minus 7 over 3, we copy it the same. Now we are having the same denominator, which is 3. Let's subtract the numerators. Note that 15 minus 7, it gives us 8. So the answer is 8 over 3. The denominator 3, we copy it the same. Thank you for watching. If you enjoyed this video, please like, share and subscribe for the continuity of our channel to support you by more and more information, with a great appreciation for your support. Thank you all.